Well, good morning. It's certainly a pleasure to be here today, and it's great to see the automotive industry become such an important part of this conference. So, Anna, thanks to you, thanks to Tony Cooprider of Ford, the executive committee, for the invitation, and certainly thanks to Dr. Moore, because he's enabled everything that I'm going to talk about. So, great lead-in. We should have a few minutes at the end for Q&A, so keep that in mind and be thinking about what I didn't cover or didn't cover very well. So while it's been around for well over a century, I'd argue that we're on the cusp of what is easily the most exciting time in the automotive history, certainly for the automotive industry. So think about how far we've come. Gottlieb Daimler and Carl Benz gave us personal mobility when they invented the first motor wagon back in 1879. And then Henry Ford made that a reality for the masses with the invention of not a product, but a process called mass production. Now, along the way, innovations like the first electric starter, the first radio, to the first airbag, and even the introduction of in-vehicle telematics and infotainment, all things which Delphi had a hand in, by the way. And there's so much more. They've redefined and reinvented the driving experience while building the auto industry's legacy of creativity and ingenuity. So for the purposes of what's relevant for you, think about the progress we've made with digital content and systems in vehicles. Today, a car which includes over 50 computers, as Anna mentioned, and as much as 100 million lines of code, is easily the most sophisticated piece of electronics you own. Now you compare that to, say, your Android phone. It uses 12 million lines of code, or the 44 million lines of code used to run Microsoft Office, or even Facebook, over 1 billion users, is at 61 million lines of code. And something as complex as an F-35 fighter jet operates with a mere 24 million lines of code. So the impact of this shift for automotive technology providers and for the entire industry has presented many challenges and many opportunities. So the good news is we've been there. We've had to adjust from moving, at least in my career, from ROM to Flash. It was a major shift in what we were doing and how we did it. Reverberated all the way through the supply chain. It was a crazy transition, but we did it. And now we're looking at over-the-air updates, for example. And that also presents challenges, right? Everything from security to reliability, but it's coming. Now, as the digital curve continues and the clock speed of business increases, we're going to be relying on design automation more than ever for improved productivity, for accuracy, and for collaboration. The importance of design automation is something I know personally, and I think about the complexity of what we're doing. I've got about 20,000 engineers located around the world working on thousands of products, highly engineered technologies and systems. Now, so let me add a little color around that. So when I started in engine controls a few years ago, we had about 50,000 lines of code involved in the entire automobile, all in the engine controls. And I already shared that you can have anywhere from 50 to 100 million lines of code on today's vehicles. So without design automation, based on the way we did work back then, I would need 200,000 software engineers working on code alone to create it and to validate it. Today, with design automation, I can get that done with about 5,000. From a geographical standpoint, design automation has helped bring us all close together virtually, even though many times products will be developed for us in 2 or 3 different locations, and certainly for our customers, with oceans between them often. The ability for engineers to work seamlessly around the world is a necessity with today's global automotive platforms and with the 24-hour work cycle. And then when it comes to execution, the value prop is just as compelling here. Design automation for designing, for testing, and validating has been instrumental in improving our flawless launch rate from about 60% back in the early part of last decade to 96% today, programs that are launched flawlessly. So for me, in dollars, that translates to hundreds of millions of dollars of engineering productivity because I don't have to redo things anymore. I don't have to disappoint customers. So clearly, design automation is what keeps our engineering machine productive. It keeps it efficient and keeps it accurate. And given today that we ship more computers every day than HP and Dell combined, for example, and we ship more than 20 billion lines of software code every day, and considering that we expect both those numbers to increase annually going forward, we're going to be relying on your industry even more. So that being said, I think it's beneficial for you to understand how we're thinking about the way forward and where we're going as a means to identify where we can push the envelope even a little bit further. And so that's what I'll focus on for the rest of my presentation, where we're going as an industry, and particularly as a company. In the simplest terms, we are moving forward. And as we do, we see the challenges and the opportunities are getting bigger in both breadth and scope. To really understand that, let's take a look at the world that we live in today. So for one, there's a global nature of our business that I already touched on. Virtually, the world is shrinking, and design automation plays a huge role in helping us deliver in a world where development cycles constantly shrink. At the same time, the rapidly changing automotive landscape requires us to learn completely new concepts within our industry and consider what is likely our biggest future challenge, and that's creating the enablers for safe and sustainable mobility. So there's a confluence of factors behind that. First, there's an increased number of vehicles on the road. Global light vehicle production will hit 100 million units per year by the end of this decade. China is already the largest automotive market, will be at roughly 30 million vehicles per year produced by the end of this decade. So if you do the math, in just a little over 10 years, there's going to be 50% more vehicles on the road in the global car park. And then you factor in the increase in population, especially within the megacities. The number of people living in cities today is expected to grow from 50% to roughly 70% by 2050. And that shift is going to be most evident in China, where there's an urbanization the scale of which the world has never seen before. By 2025, China will have added 350 million urban residents to its population. Literally the population of the United States now brought to cities in China. By 2030, they're going to have a city population of more than 1 billion residents. And the country will have over 200 cities that boast more than 1 million people each. And it isn't just China. That trend toward urbanization is happening all over. And globally, it's projected to be 34 megacities by 2025, a megacity being 10 million population or higher. And over 3/4 of these are going to be in emerging countries. So you've got more people, you've got more cars, and as a result, you've got more emissions and more gridlock. So importantly, all these changes are coming fast, and the solutions have to keep pace. So think about the speed at which we live and work. And as you know, technology has revolutionized how we learn, how we communicate, how we shop, how we do business. It's changed everything. So I have one statistic that I think puts this into perspective best. So just ask rhetorically here, how many people in the audience have preschool children? So it's pretty nice to get away for a few days, huh? So if you think about what they have in front of them, 65% of current preschoolers will work in a job that doesn't even exist today. 65%. All right, that's incredible, and it's a testament to how different our world will look in just 2 short decades. When we look at it from the industry standpoint, it's about understanding the influence that the internet and information have on customer expectations. So those expectations can be broken down into 2 buckets. First, consumers want to be connected everywhere they go, including in the vehicle. And then second, they want the technology in their vehicle to keep up with their mobile devices and their digital lifestyle. It's no longer acceptable for in-vehicle connectivity and multimedia features to lag behind mobile phone and tablet technology. And of course, any integration of these digital conveniences has to be done safely. So that gets back to just how exciting a time this is for the automotive technology world. Right now, we're asking ourselves, will we see the day that the internal combustion engine produces 0 emissions? And what's the ceiling for fuel efficiency? Can we hit 100 miles per gallon and still have a car that we all would want to buy? Can we even do better than 100? What if we eliminated all traffic fatalities? What if in-vehicle connectivity became completely seamless and 100% safe at the same time? And will this generation be the one to witness a time when autonomous driving becomes a reality? So I think all of those scenarios are within reach, and the companies that can deliver the innovations to realize those visions will be the ones to win. It's the reason why Delphi is keenly focused on the megatrends of safe, green, and connected. And being able to understand these megatrends and concentrating our R&D on solutions to meet customer expectations in these areas, I think it's the key to realizing the full potential of the perfect storm of challenges and opportunities. So excuse the PowerPoint here, but this is some detail that we've used with investors just recently. It supports the focus on safe, green, and connected spaces. It highlights the growth areas for Delphi, but if you look to the right, the market CAGRs that we expect around the world in some of these spaces as vehicles become more safe, more green, and more connected. For us, the top contributors to our growth are infotainment, it's active safety, it's systems that support greener propulsion. And I'd like to point out here that one common thread across all these megatrends is software. And in and of itself, that has a 20% CAGR, compounded annual growth rate within automotive. But in our case, it has to be reliable software. When software quality right now is the biggest contributor to automobile launches around the world, right? It used to be hardware, it used to be something mechanical, and now it's software is the thing that holds the vehicles back when they're ready to have that first vehicle come off the line, and you're still working out some of the software issues that'll make it automotive grade. One of those top issues, a software failure in our case, and the reason for automotive grade is it could literally be a life or death situation. So that more than anything underscores just how critical dependability is when it comes to software. So with these growth trends in mind, let's look at each megatrend in a little more detail, and let's start with safety. Globally, every 30 seconds, somebody dies in an accident. And that's about 1.3 million deaths per year on the roads around the world. And that's a tragedy. Now, on top of that, there's about 20 million people that are injured every year in car accidents. So governments around the world recognize the problem. They're setting goals for reducing vehicular deaths and injuries. But suppliers and OEMs all know the responsibility for getting there, the underlying technology platforms, really comes down to us. With active safety now, we can do it. Research shows 90% of all accidents are caused by driver mistakes or driver error. So it makes sense to develop active safety systems that can help mitigate driver mistakes, provide some technology help when they need some help. I think today we're at a tipping point in that logic. Safety systems are becoming more advanced. We're integrating better and better into the driver experience. It reduces driver workload and distractions. At the same time, it helps avoid and mitigate accidents using cameras, using radar, and other high-performance safety technologies, safety solutions. But I have to emphasize again here the importance of reliability. Our customers expect our products to work in every conceivable and even inconceivable situation. So again, I tip my hat to those in design automation here because thanks to things like software regression testing, it takes into account real-world conditions collected from all over the world in instrumented vehicles. By using that, we can ensure a very high level of performance and perfect the technology before it hits the road for the first time. And as a result, products like this are born. All right, this is a Raycam. This is what we call Raycam. It's the most compact radar and camera device on the market today. It's the first system to combine both a radar and a camera and the attendant processing all in a package that ends up being this small. Mounts up behind the rearview mirror where it's got a clear field of view. It's launching right now on the Volvo XC90. So it's just not the size that impresses here, the increase in performance, the reduction in cost, the reduction in mass, but this kind of technology then becomes a major building block for delivering autonomous vehicles or autonomous driving experiences. So it's not pie-in-the-sky ideology, and like I said, it is launching right now. It's literally in production as we speak, and more to come. So technology is enabling even more safety, and that's a great development, but perhaps even greater is the reality that OEMs, consumers, insurers, and other stakeholders are acknowledging that active safety features are worth the investment. Since the introduction of technologies like rollover sensors, traction and stability control, forward collision warning, and active braking, rates for the worst kind of accidents have been cut in half. So such performance is driving consumers to want it, and driving insurance companies to incentivize it, and then driving governments to require it. And we like that scenario. So switching to green. Vehicle manufacturers are also depending heavily on the supplier community to help address stricter emissions and fuel economy mandates around the world. Our three biggest markets, the United States, in China, and in Europe, all are increasing fuel economy and emission requirements at about the same pace. Here in the United States, you've got to meet 54.5 miles per gallon average CAFE by 2025, and that's a big increase if you think that we're at 30.8 last year. All right, that's a mammoth jump. In Europe, they don't have CAFE, they focus on emissions. It's Euro 6 greenhouse gas emissions. The standard here is 95 grams per driven kilometer of CO2, and that has to be achieved by 2021. But it takes the same technology. Emissions reductions, fuel economy improvement is virtually the same technology set. And then you even have China, the country that's been historically a little softer on pollution. They've now committed to aggressive limits on carbon emissions, moved up the timeline for significant emissions reductions to be on pace, maybe even be a little ahead of what the United States and Europe is doing. So governments around the world, they're driving the need for better technology, and consumers are too. If you look at the most recent Meritz CX new vehicle customer study, it questioned 200,000 new car buyers why they bought a car, what criteria they took into account. Fuel economy is still a top 3 consideration in the United States, even at the reduced fuel prices that we've seen and probably will see for some time. So we don't have our eyes just on meeting these requirements and consumer demands. We really are working to exceed them. The good news is, among all the change we see, there's one constant that we can count on, and that's that the dominant powertrains for decades to come are going to be internal combustion engines. Even as late as 2040, we expect that gasoline, diesel, and natural gas-powered engines are expected to represent 95% of the market. They just keep getting better and better. And to that end, developing solutions for more efficient, more environmentally friendly internal combustion technologies, that remains our focus. And a key enabler, of course, is advanced fuel injection. It relies heavily on software and calibration algorithms and state-of-the-art controllers. Everything from injectors to pumps must be monitored. They have to be optimized through the engine management system solutions to meet the regulatory requirements and also provide excellent performance. So we have something called gasoline direct injection, or GDI. It's a great example. It reduces CO2 by up to 15% on a 3 or 4 cylinder turbocharged vehicle. And then our diesel fuel injection offering, it has optimized engine management system. It's capable of a 30% improvement in fuel economy and a 50% reduction in toxic emissions over the Euro 5 technologies. And then in heavy duty, the medium and heavy duty trucks around the world, we've got another great example there. Our Euro 6 technology has the capability to inject fuel with up to 40,000 PSI. It enables OEMs to comply with the latest and future regulations around the world and be on par with what light passenger vehicles can produce. And then beyond that, we continue to advance other viable alternative energy solutions for future market demands. That's a lot of hybrid technology we think will be a meaningful part of the car park here in the next 5 or 6 years, and then electric and natural gas as well. All part of our green portfolio and are likely to keep key to ensuring that we're not only part of the conversation, but we're leading the discussion on the solutions the automobile manufacturers will need around the world. And then finally, there's connectivity. We as consumers, we want to be connected 24 hours a day, 7 days a week, and we want that ability even when we're in the car. Delphi's got a strong heritage in this regard. When radio became the main means of communication and entertainment, people wanted to be able to stay informed and entertained on the road. So we answered that way back in 1936 with the world's first car radio, and we've continued to push the envelope in infotainment ever since and given the world telematics. So today, every one of our platforms has the ability to connect to the cloud, to connect to the internet, right? It's no longer onboard content, it's offboard content that's accessible with every program we're doing everywhere in the world. So today, thanks to people that drive the digital curve, thanks to Gordon Moore, the traditional idea of telematics and infotainment has truly expanded. Connectivity is something that touches nearly every part of the vehicle. It is connected to architecture, the underlying nervous system, that will help define the future driving experience. Underneath the skin of a vehicle, you can have anywhere from a 1.5 to 2.5 miles of electrical architecture. that hooks all of this technology up, enables it all to perform, and you're able to run diagnostics. It enables a complex interchange of data, and it provides the power and the signal to enable all the features and functions that you experience as a consumer. So consider this. When you first start up your car, just in that first 2 seconds, over 100,000 pieces of data are exchanged around the entire vehicle architecture. Over 100 diagnostics are pulsed just in the first 2 seconds. And then that continues ad infinitum as long as that car is powered up. And then you think about digital distribution rates, if you will. Right now, the digital data is distributed at about 65 megabits per second on about 300 diagnostic parameters. We're working on programs that will launch in the next 3 or 4 years where the data increases dramatically to 1.5 gigabits per second on over 1,000 diagnostic parameters, and I'm sure it's going to continue ad infinitum. We're moving toward a state where nearly every system in the vehicle is networked for maximum performance. It's about allowing the drivers and the passengers to safely connect to their media, and it's about allowing the safety systems to talk to the brake systems, that talk to the powertrain systems, et cetera, et cetera. It's about reconfigurable displays and even reconfigurable ride and handling. It's about vehicles that are able to talk to the infrastructure, vehicle to vehicle, vehicle to infrastructure, and then certainly being able to talk to each other. So if it sounds complex, it is. In the automotive world, this is really tough. But it's forced those who want to play in this space to evolve from offering just commodity components to developing high-tech, highly engineered, world-class systems. And that includes automotive-grade software. Automotive-grade software that performs to the very high expectations of the automotive environment. So nothing speaks to where we think the future of connected vehicle technology is heading louder than the partnerships that you need to have to be successful here. Nobody does all this anymore at all. We work with companies like Apple and Google, NXP, Freescale, TomTom, Mobileye, and more to ensure that our code works with theirs, that we can provide a suite of benefit that the consumers want or the automobile manufacturers want to include to differentiate their product. And then we also look to collaborate at the highest levels to ensure that we have the best of both worlds, both automotive grade and performance. So, for example, we work with NVIDIA on a high-end microprocessor solutions. We work with AVL to enhance powertrain engine management systems. We work with QNX to provide an operating system that enables a range of infotainment features. Mobileye to bring vision algorithms into our active safety systems, and on and on and on. It's conceivable that not too far down the road, when we talk about the fastest vehicles, we won't be talking about miles per hour at all anymore. We'll be talking about connectivity and processing power. So with more and more electronics, you can either increase the number and the computing capability of each controller in the system, which the industry has traditionally done over the last 30 years, or you can start to move to the first real architectural shift that I've experienced, certainly in my career, something called a multi-domain controller. It enables each of the sensor controllers to maintain basic operation, but you simplify the architecture. You put a bunch of computational capability central for a particular zone of activity. In this case, it starts with active safety. It enables fast, high capacity, fast data exchange, real-time decisions that the vehicle may need to make to help the driver or to take over control of the car to avoid or mitigate an accident. So Audi happens to be the early adopter here that's leading the charge here, but many car companies are right behind. We actually go to market with this next year in 2016. It'll be one of the most sophisticated piece of computational capability that's ever been on the car. It's got enough horsepower, finally, to truly allow updates and additional content to be added down the road, and essentially this is an opportunity for the first time to hit that holy grail of future-proofing of vehicle architecture. It's been very easy to talk about, it's technically been able to do, but this is one of the first times that it's actually being implemented from the ground up. So, safe, green, and connected, certainly Delphi's future. Our ability to provide solutions in all three areas, along with our unmatched systems integration capability, is what we believe will drive our success. Focusing our portfolio, strengthening our integration competence puts us in a strong position to not only provide solutions to these megatrends, but also to exploit synergies as these megatrends converge. A good example of convergence is in safe and connected, for example, and when they both come together to see the possibilities, like in the user experience in the cockpit, like gesture control, where you might use simple, intuitive gestures to change songs or adjust volume. The simple, intuitive user experience gives the driver more connectivity, more control, and it's safer. It's safer than the alternative ways that you might make those machinations. It's a real sweet spot for Delphi, but particularly as they converge. And if you think about maybe the ultimate convergence here of all three megatrends, safe, green, and connected, that's where automated driving comes in. So automated driving really does represent an opportunity in all three of the megatrend spaces of safe, green, and connected. The foundation for automated driving, it started long ago. We started automating features a long time ago. We introduced the first cruise control, for example, back in the late 50s. It was on the Cadillac Eldorado. Now, since then, we've added other building blocks like radar and vision, vehicle-to-vehicle, vehicle-to-infrastructure kind of communication, and there'll be many more building blocks that are going to be required here. So, no doubt it's a journey to get to where we are, and we've still got miles to go to get there. But we got a real taste for the possibilities of this convergence during our recent coast-to-coast automated drive. Hopefully you've heard something about that. I want to tell you a little bit about that, but before I get into the details, let's take a look at the video highlight reel here.
One of the most buzzed about showings at the Consumer Electronics Show was a preview of the driverless car. We can expect to see urban driverless technology like this hit the market in the next 10 years. For the PBS NewsHour in Las Vegas, I'm Steve Goldblum.
The idea for this trip came about after a very successful show in CES 2015 in January. So we started to think, what would benefit the technology, and also what would help us prove out that this car is capable of moving to market quickly. We decided that collecting 2.5 terabytes of data and being the first to go coast to coast in the United States with a self-driving car or an automated car would be pretty compelling. How does a car drive itself? An analogy that we like to make when you ask is think about how a human works. If you think about your eyes, your ears, and your nose as the sensors, the same thing happens with vision and radar and laser on the vehicle. The controller is kind of like your brain, and the smart logic and the software that runs on that is really the heart and soul of how the car drives itself.
So what our coast-to-coast drive did, it was really big in terms of what we demonstrated and certainly what we learned. So I had a chance to ride with a team from Philly up to New York City, the last leg of the trip, and I got to tell you, it's quite an experience. I just had a short portion of the roughly 3,400 miles that the car traveled. It hit 15 states in 9 days, faced with a lot of different weather conditions, a lot of different traffic conditions. Clearly, that's why we wanted it out there, is to understand how all the different technologies might individually and collectively perform in all the weird things that happen on the driving environment that we all experience every day. We still, even with all that, we still managed to operate in automated mode close to 99% of the time, with far more than we thought we'd actually be able to do. This vehicle is equipped with 20 sensors, has radar, vision, LiDAR, vehicle-to-vehicle. It has high-def GPS. It's got sensors mounted all around the vehicle. And of course, you wouldn't put a car in production like that. This was an engineering development vehicle for sure. But they were all styled into the vehicle so that they were relatively invisible. Please take a look. The vehicle's located out in the exhibit hall there. And we've got one of our experts, one of the team members that put this together and took the drive, and he'd be able to answer any of your questions. But try to find the sensors, right? Most of them are styled in so cleverly that you can't even tell they're there. You don't have a big LiDAR on top, that's incredibly difficult to style in. This is done as the OEs would want it done to be able to offer a production vehicle to the consumer world that included a lot of this technology. So I think the team did a great job of styling it. Take a look. We learned a lot, like I said, from this test. We learned that our car was, I'll say, overly cautious around semi-trucks and oversized loads, for example. It really biased to the left side of the lane when you pass something on the right. But we do that as a human too. But technology-wise, there was no reason for it not to be exactly in the center of the lane. So that was an interesting filing, and also one that's pretty easy to change. We learned that radar technology works really well in all kinds of weather. It works well in tunnels. It works well in the really big steel bridge structures where we crossed a couple of the major rivers. It's kind of a radar engineer's nightmare, if you will, with the 76 gigahertz energy bouncing around, and you're only wanting to get the signal back and discriminate on what's in front of you. So worked absolutely flawlessly. We learned that vision system can have a little bit of difficulty on a low sun angle, right? So early morning, sun up and sun down, and then we also learned in inclement weather there were some challenges perhaps there. But we did learn that having radar and vision together was a sensor suite that was absolutely second to none and provided a really robust definition of what was in front of the vehicle, so you can make mission critical safety kinds of decisions. We also learned that lane markings across the United States are significantly different. Surprisingly, there isn't necessarily a federal standard on this that would make them all look the same. So sometimes you got a continuous white line, sometimes you got a dash. Some cases it's dot bots. In all cases, most of them have been there for a while, so they're scuffed over or black marked out, but you still are dependent on being able to see some lane edge definition to understand where you are if you're not going to rely on high-def GPS or pre-mapping, if you will. So again, we learned a lot of that and a lot of things that are going to make our technology development more powerful. So the bottom line is we made a conscious decision some time ago to focus our portfolio on safe, green, and connected, to be very best at delivering highly innovative solutions that solve our customers' biggest challenges around the world. And it's certainly proving to be the right decision to have made. To quantify that statement, we're working on vehicle solutions that will enable 50% fewer emissions, 100% better fuel economy, 50% fewer accidents, and 1,000%, maybe 10,000% or more connectivity, all by 2025. But we realize that our success hinges not only on what we do, but also on how we do it. Execution has been equally as important as technology. In the case of automotive grade means everything to the automobile manufacturers and the governments around the world. So in addition to a focus on innovation, Delphi's been relentless in building a culture of collaboration and excellence. In an automotive industry, we're held to extremely high standards. Both our OEMs and their consumers demand flawless manufacturing and performance. It's a phenomenal feat when you think about it in the perspective of the volume we produce on the micro level. At Delphi, we build about 60 million parts every day, and that's at about 2 problems per million, or 2 ppm % quality rate. Nearly flawless production. It's shipped on time every time around the world, and this year we'll launch another 12,000 new programs for customers, and hopefully with as good or even better execution success. So outside the medical industry, that kind of flawless execution is really unheard of, but that's what the automotive industry requires. So I'll finish with this. Innovation, collaboration, excellence, it really is a formula for success, regardless of what the future brings. And while I won't predict the future, I will guarantee that regardless of where the market takes us, design automation will definitely play a huge role. And of course, we won't be cruising to the future. It's going to take a lot of effort. Customer expectations are high, and there's a lot of worthy competitors. I mean, we all know that. It's a tough environment, and I believe it's going to drive us all to even greater heights. An innovation portfolio and flawless execution will certainly get you in the game, but it's the companies that can anticipate the right technology to invest in and the right ways to execute, both from a manufacturing footprint and customer service aspect, that are going to come out on top. And for us, we look forward to the task. We're ready for the future now. With that, I'd be happy to take Q&A. We've got just a couple of minutes. There's a microphone in both aisles if somebody's got a couple of quick questions. Okay. Yes.
One question, if you don't mind. Regarding security, so access, intrusive, or attacks on vehicles, for example, that might penetrate these communication firewalls. Why do you talked about obviously green connectivity, and aspects like that. Where does security enter the picture?
Well, security is an underlying fundamental requirement for all aspects of the electronics and the serial data communication on the car, right? I mean, and the more you have, the more of an opportunity, the more of the threat that can be. So that's going to be a constant journey to make sure that the individual technologies, the systems, and the vehicles are as impenetratable to mischief or cybersecurity kinds of concerns, from the encryption to the authentication codes, to the firewalls, to the data gateways, if you will. I mean, they're all things that we use today, but that's going to be an ongoing challenge for the industry to make sure that we're staying ahead of that and keeping the consumers and our roadways safe.
All right, thank you.
One more here.
Yes, my background is in avionics software, specifically flight critical software. And we're levied on FAA standards, certain standards for process to achieve flight certification. One of them is called DO-178B, and a subset of that is MCDC. In ISO 26262, there is also a suggestion for MCDC testing, but it's absolutely mandated by the FAA. And I was wondering if you understood why that is not mandated and how that plays in, and especially in the safety critical areas of the software and of the hardware, you know, DO-254 in your software and your systems.
Yeah, man, you're throwing a lot of numbers out there. Certainly ISO 26262 is going to be fundamental to the automotive architectures of the future. It's being required by customers and will be required by governments going forward, especially in the mission critical parts of the car. I can't answer your question in terms of why it doesn't include more of what the avionics industry would require. I'm not familiar enough to know, but I can get you hooked up with some of our experts that might be able to answer it. Yes.
In the aviation industry, Boeing and Airbus have a very different philosophy for the autopilot. Who gets to take over in an accident? Where do you see the autonomous driving going? Would there ever be a situation where the computer gets the final say? Do you have any studies on that?
Well, I think being able to take the driver out of the driver's seat, you know, ultimately, I think is quite a ways down the road. I think you're gonna want to have a driver there, reasonably alert, that can take over in the event that the technology needs some help. But I think we can bring a lot of technology to bear to assist the driver and maybe even override, or I'll say not be distracted if the driver is distracted, and take appropriate action at the vehicle level that the driver isn't prepared or isn't aware to take. But ultimately, taking the driver out of the driver's seat, I mean, we've not been able to do it in an airplane yet. There's a lot of reasons for that. I think there's going to be a lot of reasons why it's going to be difficult to do in the automotive space. But I think a lot of safety benefit will accrue on the journey on the way there, in terms of having the vehicle be much more able to detect and avoid potential accidents and then avoid them, even take active control. So stay tuned. It's going to be a journey in the automotive space.
Great, thank you.
Yeah.
Thank you very much.
Thank you.
Jeffrey, sorry it's heavy. Thank you very much.
Thank
Great
you.
talk.
Thanks for having me.